Let's take a look at the fundamental counting principle in a couple other scenarios. So suppose we toss a coin and then we roll a die. So how many outcomes are in the sample space? So if you're tossing a coin and then rolling a die, there's going to be two stages. Alright, so the first stage is what can happen on the coin. And the second stage is what can happen when you roll that die. So for the first stage, how many outcomes are possible on the first stage? There are two possible outcomes. We can actually start drawing a tree diagram to even visualize what's going to go on. So on the first stage, now I'm going to draw my tree going down so you can see just a different way of organizing it. So on the first stage, this is what happens on the coin. They could be heads or tails. Now on the second stage, which is when you roll a die, how many outcomes are possible when you roll that die? There are 6 outcomes. Now you could either get a 1, 2, 3, 4, 5, or 6. So how many outcomes are there going to be total if you toss a coin and then roll a die? There are 12 outcomes total. We're going to multiply those numbers together. So to finish this tree, so you can see what the 12 are, 4, 5, 6. Alright, so the outcomes would be then, if I were to start listing them down here, I could get a heads and then roll a 1, heads and then a 2, heads and then a 3, heads and then 4, heads and then a 5, heads and then a 6. And then I could also have the tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6 to finish out my 12 outcomes. Now, as opposed to doing a tree diagram, you can also make an orderly list. So here's an orderly list for this example. So suppose we roll a pair of die. Okay, so you're going to roll 2 die, and you're going to consider the sum of the 2 numbers rolled. Now the first question is, how many outcomes are there in the sample space? So we have this organized over here in this table. This is showing us what can happen on the first die and what can happen on the second die. So sometimes when we go to record these outcomes, they're recorded as like ordered pairs. So like for instance, this first one would be considered a 1 on the first die and a 1 on the second die. Okay, so we don't like to do it as like a 1 1 because that looks like an 11, right? So as like opposed to these ones where we like squish them together, it doesn't look really good on these ones because, for instance, like this 1 and then 2 looks like a 12. So to be very clear about what's happening on the first die and what's happening on the second die, we sometimes write it as an ordered pair. So this would be getting a 1 on the first die, a 1 on the second die. This would be getting a 1 on the first die, 2 on the second die. Contrast that with this one right here. This would be getting a 2 on the first die and a 1 on the second die. And just as these would be different ordered pairs plotted, if you were to plot them on the Cartesian coordinate grid, we are going to consider these to be different rolls. This is a 1 first and then a 2 second. This is a 2 first and then a 1 second. So that's going to be considered different. But right here, this would be a 2 and then a 2. If we flip them, we don't consider that to be different. Just the same way in an ordered pair, we wouldn't consider that to be a different ordered pair. So this comes all the way down here to 6 and then 6. So how many outcomes are there total in the sample space? Well, there are 6 ways that the first die could land, the numbers 1 through 6. There are 6 ways that the second die could land, the numbers 1 through 6. So overall, there are 36 outcomes in the sample space. And those 36 are listed over here for us. So let's kind of use this table to answer some questions about probability. So determine the probability that a double is rolled. So the probability of a double. Alright, so a double. So who would we want to count here? So again, we have 36 rolls total, so that's going to be my denominator. I want to find out in this table how many of them satisfy being a double. So this is going to be a double, right? 1 and the 1. That's a double. There's one here, one here, one here, and one here. So there are 6 ways that I can get a double out of the 36 possible rolls. So then this probability simplifies to 1/6. Next one, let's determine the probability that a sum of 4 is rolled. So in my denominator, I have 36 possible rolls. So I'm going to go ahead and erase these. All right, so where could I get a sum of 4? So this gives me a sum of 4. It'd be getting a 3 plus 1, so that would add to a 4. This sums to 4, and that sums to 4. And that's it in this, out of these 36 possible rolls. So there are 3 ways that I can build a sum of 4 out of the 36 possible rolls, so this simplifies to 1/12. So I'm going to get rid of that. I'm going to change that to not being read. All right, so part D, are each of the possible sums equally likely? No, they are not. All right, so the possible sums you could get, the smallest sum you could get would be a 2. Right, getting a 1 and a 1, that would be the smallest sum. The largest sum you could get would be getting a 12, which would be a 6 and a 6. If we start looking at all the different sums in here, this is actually going to be the most likely, getting a sum of 7. It could happen here, 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 and here. All right, so a sum of 7 is the most likely, and the least likely are going to be the sums of 2 and 12. Each one of those have 1 out of 36 possible rolls in occurring. So because the sums are not equally likely, when we go to figure out the probabilities, we break it all the way down into outcomes that are equally likely. So these 36 outcomes, each of these possible rolls are equally likely to happen. So we use these to base our counts when answering questions about looking at sums when we roll 2 die.